A self-tanning lotion advertises that a 3-ounce bottle will provide 5 applications. Jen found a great deal on a 16-ounce bottle of the self-tanning lotion that she'd been using. Based on the advertising claims, how many applications of the self-tanner should Jen expect? Let's begin by noticing that a 3-ounce bottle will provide 5 applications. So we can write that as the given ratio of 3 ounces over 5 applications. Now that has to equal the ratio on the other side. And notice that we're told that Jen has found a 16-ounce bottle. The 16 ounces, we have to decide if it's going to be written on the top or the bottom of this other fraction. So notice that in our fraction on the left, we wrote ounces over applications. So on the right, we're going to put ounces on top. Applications would go on the bottom, but we don't know how many applications. That's what we're trying to find. The question says, how many applications? Since we don't know it, we're going to call it x, or you could use a different variable such as n. And I'm writing applications at the units just to be consistent, and so it's the number of ounces over the number of applications on both sides. On the left, we knew both of those values. On the right, we knew the 16 ounces, and we're looking for the unknown number of applications. We now rewrite the same proportion without the units. You might wonder, why don't we start there? Wouldn't it be faster? And though it might be faster, keep in mind if we had started by just writing 3 over 5, we might not remember whether or not the 16 goes on top or on the bottom. You have to follow the units in these problems. So now we're ready to cross multiply. It doesn't matter which cross multiplication you do first, but I'm choosing to do the 3 times the x first. I like to do the one that involves the x. This way my 3x is over there on the left. And it equals the cross product of the opposite diagonal, which is 5 times 16. And I'm writing that multiplication by showing it with parentheses. You could show it other ways. I don't like to put an x for multiplication because it could be confused with x the variable. I simplify the 5 times 16, and since I'm out of room, I'll bring this up to the next column. To proceed, we want x by itself, and it's currently being multiplied by a coefficient of 3. So I'll divide both sides by 3. The 3's cancel, and so x equals, and now I have to simplify 80 over 3, and I'm going to do that using a calculator. Remember when you enter this fraction into your calculator to type 80 divided by 3. It's the top divided by the bottom. It's not just because it's the bigger number. When you're doing this on the calculator, it's always the top divided by the bottom. And my calculator gives me something along the lines of this, so now I have to think about rounding. Notice in the directions, it says round down to the nearest whole number. The whole number is being pointed at right now. It's where the 26 is. And so I want to decide what to do with that 6. Normally, I would look at the 10th place, which I've circled, and it would tell me what to do with the 6 that's in the 1's place. And again, normally, since that 6 is 5 or greater, I would have rounded this up to 27. However, that's not correct. Notice the directions say round down to the nearest whole number. Why might they say that? Well, because in this application problem, Jen needs to know how many applications she gets. And so because it's not quite 27, if we round up to 27, then when she gets to the end of the bottle, she won't have enough for that 27th application. And so when you get a question like that where there won't be enough, even if it was 0.9, we would still round down to 26. And because it's a word problem, I want to put the units there, and this was how many applications she got from that lotion. And again, she gets 26 complete applications. She doesn't quite get that 27th. And that's our final answer. The school's computer lab goes through 5 reams of printer paper every 7 weeks. Find out how long 3 cases of printer paper is likely to last. Note that a case of paper holds 8 reams of paper. Let's begin by talking about a ream of paper. This question says that 5 reams of paper last us 7 weeks. So we can begin and write our first ratio. 5 reams over 7 weeks. Now what will that equal? Note that it says we have 3 cases. But how many reams is that? There's a hint up in the question that says a case of paper holds 8 reams of paper. We already talked about what a ream is. Now we'll talk about a case. A case is a box of paper that holds several reams. For this problem, it says it holds 8 reams. Let's continue our problem and figure out how many reams we have. It says we have 3 cases, and each case contains 8 reams. 2 cases, 3 cases. To determine the total, we don't want to count them up. The quicker way is to multiply. 3 times 8, which is 24 reams. Now we need to determine what goes on the bottom. Since we have weeks on the bottom on the left, now we'll put weeks on the bottom on the right. But we don't know how many weeks. We're trying to find out how long it will last. So that's X weeks. We can now write this proportion without the units, and we can cross multiply. 5 times X is 5X, and 7 times 24 is written on the right. So 5X equals 168. Now we want to get X by itself, so we're going to divide both sides by the coefficient of X, which is 5. The 5's cancel, and we will use a calculator to do the division on the right side, the top divided by the bottom. So X equals 33.6. Note that the question asks us to round to the nearest whole number as needed. And so this one can be rounded by looking at that 6 that's in the tens place. Since it's 5 or more, we'll round up. So X is approximately 34 weeks. Which means if we have 5 reams of paper that last 7 weeks, then 3 cases of paper should last about 34 weeks. The adult daily dosage for a certain medicine is 90 milligrams of medicine for every 20 pounds of body weight. Part A says, at this rate, find the daily dose for a man who weighs 185 pounds. We can solve this using a proportion and noticing that the question tells us that 90 milligrams of medicine are needed for every 20 pounds of body weight. We can use this to set up the ratio on the left-hand side of our proportion. But now we have to find the right-hand side. Part A tells us that he weighs 185 pounds. And we need to determine if that goes on the top or on the bottom. Remember, you need to keep your units consistent from the top to the bottom. So since the left-hand side has 20 pounds on the bottom, we'll put the 185 pounds on the bottom of the right-hand side. What about the top? The question asks us to find the daily dose. Since we don't know it, we'll call it X. And since the dosage is measured in milligrams, we'll call it X milligrams. Now, since our proportion is set up, we check the units and they're consistent, so we can rewrite our proportion without the units. We're ready to cross multiply. I like to find the one that involves X, and so that diagonal is the 20 times X, which gives us 20X. And the other diagonal is 90 times 185. So we can use our calculator to simplify. 20X equals 16,650. And then we need to divide both sides by the coefficient of X. We want to get X by itself. So that's dividing both sides by 20. And the 20s will cancel. To determine the right-hand side, we'll use our calculator. The top divided by the bottom, which gives us X equals 832.5. Because this is a word problem, we want to be sure to pay attention to the units. And so we were finding the milligrams. And that's the answer for part A. Now on to part B. If the man is to receive 500 milligrams of this medicine every 8 hours, is he receiving the proper dosage? So the key is he's getting 500 milligrams every 8 hours. Let's focus on that 8 hours. We need to know how many times he'll receive the medicine in one day. Since there are 24 hours in a day, and he's receiving this medication every 8 hours, we can divide 24 by 8 to figure out how many times he'll receive medicine in a day. You can use your calculator, and that gives you a result of 3. He'll receive the medication 3 times per day. Let's go back to the fact that he's receiving 500 milligrams of this medication each time. And we've already determined that he's going to receive it 3 times each day. So we can multiply to see how much he'll get in the day. 500 milligrams times 3 is 1,500 milligrams. The question we're being asked is he receiving the proper dosage? In part A, we determined that the proper dosage is 832.5 milligrams. In part B, we realize he's scheduled to receive 1,500 milligrams. Now these wouldn't have to be perfectly identical, and I'm not a nurse or a doctor, but I think it's pretty safe to say he's scheduled to receive way too many milligrams. So we can answer our question. No, he is not receiving the proper dosage. The gas-oil ratio for a certain chainsaw is 25:1. Part A asks us how much oil in gallons should be mixed with 13 gallons of gasoline. The key is to notice that it's telling us that the ratio is 25:1. But what are the units? At first it might appear there are no units. But if we look at the sentence more carefully, it says the gas-oil ratio. Since they wrote gas before oil, then the 25 will line up with gas and the 1 with oil. We're writing gallons of gas and gallons of oil. We actually could use any unit at that point, but since our question is in gallons, that will be how we'll proceed. What do we write on the right side? It's telling us that there's 13 gallons of gas. Does that go on the top or on the bottom? Well, since the left side has gas on top, the right side will have gas on top. So the 13 gallons of gas goes on top. What goes on the bottom? The question is saying how much oil in gallons. Since we don't know, we call that X. And the units, as it states, are gallons of oil. Since we've written our proportion and we've carefully checked the units, we can now rewrite the proportion without the units. And we're ready to cross multiply. 25 times X is 25X, and the other diagonal is 1 times 13, which simplifies to 13. Now we want to get X by itself by dividing both sides by the coefficient of X, which is 25. The 25s will cancel on the left, leaving us only the X. On the right side, we want to simplify by using our calculator. We'll divide the top by the bottom. Notice that a common error when you're going to use your calculator for a division, there's a tendency to want to divide the bigger number by the smaller number. That would be a mistake. You always want to do the top divided by the bottom, which gives us 0.52. The units we can remind ourselves by looking back at the question, or better yet, if we look at the proportion, we can see we were looking for X gallons of oil. So this is our gallons of oil. Now on to part B. If 1 gallon equals 128 fluid ounces, write the answer to part A in fluid ounces. The key is that they're giving us the conversion factor from 1 gallon to fluid ounces. And we can think about a gallon. I'm going to think about a gallon of milk because I think it's something that most of you have visualized. And this is telling us that that 1 gallon holds 128 fluid ounces. So we could have any number of gallons. In this case, I just wrote 3. And we would see that each of them would have 128 fluid ounces. So if we wanted to know how many fluid ounces were in all of that milk, we could multiply 3 times 128. But we don't have 3 gallons. We have 0.52 gallons. Fortunately, the same technique applies. We'll multiply our gallons by the conversion factor of 128 fluid ounces. We simplify using a calculator, and we get 66.56 fluid ounces. We're not quite done. The question says, round to the nearest whole number as needed. So we have to look at the tenths place, which I'll circle here, and that's where the 5 is. And we'll use that tenths place to tell us how to round the 6. Since the tenths place is 5 or greater, we'll round up, giving us 67 fluid ounces. Now, since the 0.52 was gallons of oil, the 67 is fluid ounces of oil. To summarize, if we have 13 gallons of gasoline, the proper amount of oil to mix in can either be stated as part A, 0.52 gallons of oil, or part B, 67 fluid ounces of oil.